Welcome back everyone. My name is Pedram and this is where we do machine learning codes and concepts. Let's get started. All right, so now let's do the boosting algorithms, the Python part for module 10. So in the previous couple of videos, we covered the Python for bagging models. We did a separate video for bagging regression and bagging classification. This is the third video that we're going to cover boosting, and I'm going to do the classification. The regression is going to be pretty much the same. So I will cover all the 5 models that we talked about in theory lectures and see how we can do it in Python, right? So we had 2 theory lectures for the boosting models, module 10 part 2 and module 10 part 3. In part 2, we covered Adaboost, GBM, and XGBoost. And in part 3, we talked about the details of XGBoost versus CatBoost and LightGBM. Now, here we're going to talk about the Python one. So go to module 10, bagging and boosting, Python, boosting, and here's the dataset. The dataset is going to be the same as what we covered for random forest classification, which is credit card default. And this is a pre-processed version that we're going to work with. And then, here's the notebook. You can go ahead and open it in Google Colab. The link should work. And however, I'm gonna run it on my local computer. So if you want to do it in Google Colab, you have to. The easy way to get access to all XGBoost, CatBoost, and LightGBM is to install it through Pycaret. So go ahead and install Pycaret, the full version. And actually, at the very beginning, you should do something like this: pip install, no exclamation, pip install Pycaret, and then open close bracket full. So you have to make sure that this is a full version, otherwise you don't get access to all the models. So go ahead and run it. I'm not going to do it on the cloud, so I have already installed Pycaret on my local computer, so I'm going to do it there. Okay, so let's open it up. So this is, let me actually go to the beginning of it. So this is the notebook. So in the previous videos we covered classification, regression, random forest regression, random forest classification, and this is the boosting classification. Okay, I'm not going to do a video for regression, but that's pretty much the same. All right, so let's connect to the right kernel. This is my Python environment, Pycaret. Let's run things. Again, we are going to cover Adaboost, GBM, XGBoost, CatBoost, LightGBM using scikit-learn and Pycaret. Okay, let's go ahead and import the libraries. And the dataset is exactly the same one that we talked about in random forest classification. So this is a credit card data set. So please make sure that you watch this video first, because I'm not going to spend some time on the data pre-processing. We have done this before. So randomness state 1000, this is the head of the data set. We are trying to predict if somebody's going to default or not by looking into a bunch of variables. So we have to go ahead and change these ones from strings to some numbers. We can leave it as categorical because random forest, XGBoost, all these boosting models can handle categorical variables. And so that's it. So we're gonna do that kind of pre-processing, and we have done this before, but I need to run it to make sure that it's working. So there's no duplicates, getting rid of the duplicates, and then here's where we are labeling the data. So we have 3 sets of different categorical variables: ordinal, label, and then regular categorical. So we have done this before. So we are using ordinal encoder first to change the education. Then we're going to do label encoder to change the, let's say, what are the 2? Yeah, sex and marriage. And then we're going to change all of them to simple categories. So this is what we're going to do. We're going to make them all categories. Now the dataset is ready with all categorical variables, and we know that we have no strings in the data, so those are numbers. So this is the head of the dataset. The data is ready to be passed to our models. Again, if this was fast, please make sure you check out my previous video when I talk about this data pre-processing steps in detail. So we spent, I think, 20 something minutes to talk about it. All right. So this is a classification task. We look at the balance of the data, 77, 22%. And yeah, our target variable is defaults. Our features are going to be everything but the defaults and the ID, which is not informative. Sometimes IDs are informative. You can do some kind of text analysis and infer something from them. But here the IDs are simple numbers starting from 1 through some 30,000, which is really not informative. So we can dump it safely. All right, so let's go ahead and let me actually save this one. Yeah. Let's go ahead and import all the models that we need to work with. So from scikit-learn ensemble, we can import a random forest classifier. I'm going to use this as a benchmark. Again, we have covered this before, but I'm going to use it as a benchmark in this notebook. And then from the same module ensemble, we're going to import Adaboost classifier, gradient boost classifier. Again, we're not going to do a video for regression, but if you want, you have to do Adaboost regressor, as you can see, and gradient boost regressor. So that's it. But we're going to work with these two now. All right. So, okay. So installing XGBoost. If you have installed Pycaret, then XGBoost 2.0, actually the latest version, is available using Pycaret, right? So let me actually quickly double check and show it to you. Okay, so here's our terminal, the Anaconda terminal. If you do Conda, so this is my Anaconda prompt terminal, so you have to just look for that, either in Windows or Mac, right? So here, if I do Conda environment list, so here's a list of environments that I have. I have finance, Pycaret, and then it's just the base. So I can go ahead and go activate the Pycaret one. I just want to check out, so this is, now we're in the Pycaret environment. I want to check out what packages do I have here. If I do Conda list, it's going to give me the list of packages which is already installed, and XGBoost should be one of them. So if you scroll down all the way, yeah, XGBoost is there, and then as you can see, the version is 2.0.1. So this is the XGBoost 2.0 version. So that's the latest version, which comes with Pycaret 3.0. So I don't need to do it this way. If you don't want to install Pycaret and you just want to use XGBoost and as a standalone model, you have to go ahead and do pip install XGBoost. That's simple. So here's the documentation. You can click on it, check it out, and then basically we'll go to the installation, so installation guide, and see what machines are you at. And then, yeah, we can do Python. You can install through Conda or simple pip install. So I can do pip install XGBoost, or if you have Conda environment, you can do Conda install Conda forge Py XGBoost. Okay, so yeah, that's, and again, this is a standalone package. You can run it in R, Python, C++, Julia, you name it. Okay. However, yeah, I think, yeah, in order to get access to XGBoost, you don't need to do Pycaret full version, but for CatBoost and LightGBM, we do need that. So this is where you can get access to XGBoost. So once you have that environment set up correctly, you can, when you run this line, it shouldn't give you any error. So from XGBoost, import XGBoost classifier. There you go. Now we have all the models. Well, at least the ones that I want to cover first, and then we get to the CatBoost and LightGBM using Pycaret. So let's train all these models. So I'm going to go ahead and do the % sign to just keep track of the time. I want to compare the performance of these models as well as the speed of these models, right? So I'm going to do % time. So this is our random forest classifier. So the benchmark, train it. And well, did I not import? Okay, it's not defined. I forgot to run this, so okay, it should be good now. So let's run it. All right, so this is gonna take some time. Yeah, the wall time is 4 seconds, right? 4.16 seconds, right? So now I want to compare this one with the other models, and let me scroll down and run for the other models. Okay, so that was the random forest, 4 seconds. Now let's quickly do the Adaboost. So again, Adaboost classifier, and then you can go ahead and read the documentation from scikit-learn as well, but it's pretty standard. You know, the hyperparameters are pretty much the same as all the other decision tree based models. So let's do Adaboost. Adaboost is a lot faster, so the wall time is 1.2, and we have to look into the wall time, right? Because let me actually run the random forest one more time, because I want to make sure that, yeah, it's reading the information from the heart, and then network time, everything. So yeah, that's fair. So the wall time includes the disk time, network time, CPU time, all of them together. So this is the real world time. How long did it take? So 4 seconds. The Adaboost, as you can see, it's a lot faster, but the performance is not going to be the best. The GBM is going to be one of the best performers, but it's going to be slower. So let's see how long does that take. So I'm running it in a different machine, so probably it's going to be different from what you saw there. It should have been 19 seconds, but let's see. Well, it's a lot more than any other. So it's 11 seconds, right? So the gradient boosting machines, the classifier took 11 seconds. So far the Adaboost is super fast, right? And then we have to compare the performance as well. So let's actually do the XGBoost. For XGBoost though, I have to make sure that this feature is turned on, enable categorical, right? Because the older version of XGBoost, I think the prior versions before 1.5, they were not able to handle categorical features. But after 1. Did I say 4.5? So after 1.5, the version 1.5, now they are able to handle categorical features as well. But you have to specify that there exists categorical features in the data, so just be aware of it, right? So that's why I have to switch this thing to be on. So XGBoost classifier, and then you can specify different stuff as well. You can, for example, say max depth is equal to what, eta is equal to, this is the learning rate. And to be fair, these are the same as the default values for example, GBM. So the default value for GBM max depth was 6. For Adaboost, I think that's the same story. So that's what, in order to make sure that it's a fair comparison, we're going to specify max depth is equal to 6, right? So let's go ahead and run this. And as you can see, it is crazy fast, right? It's just blink of an eye. This is XGBoost, right? So 114 milliseconds. So every single time, 100 milliseconds. And just compare this one with 11 seconds, right? Or with 1 second or 4 seconds. So as you can see, XGBoost is crazy fast. And I think we talked about it in the lecture video as well. So here there was a slide. Yeah, we looked into these ones. XGBoost was fast and the performance was also good. So look at that. This is fast and at the same time the performance is good. LightGBM was fast, but not sorry. The Adaboost was fast, but the performance is not necessarily as good. So now we know time-wise which one is a lot faster. The answer is XGBoost. The next one is Adaboost. The next one is GBM, and the next one is the next one is Random Forest, and the next one is GBM. But performance-wise, let's compare the performance. And because this is a relatively imbalanced data set, we can look at F1 score as well as accuracy, right? So let's train these models. We already trained these models, sorry. Let's go ahead and make some predictions in a test set. So I'm going to say y hat Random Forest, y hat Adaboost, y hat GBM, y hat XGBoost. So let's run it. Now we have all the predictions. Now with this prediction, we can go ahead and calculate accuracy, F1, precision, recall, you name it, right? So let's go ahead and import those functions and then run them. I'm going to print the accuracy for basically first one, Random Forest. This is a function accuracy score, actuals, predictions, right? So the predictions are going to be different from different models, right? And I'm going to use f strings to just print it out. So let's go ahead and run this. There you go. So let's look at performance wise, which one is better. So it seems that Adaboost is 81.93 is the best. Then Random Forest 82, then GBM. This is accuracy. 82.1, 82.3. So this is pretty much all the same, but look at the time-wise. XGBoost was a killer, right? It was a lot faster. So overall, if I want to look at the accuracy, a combination of performance and speed, this is my absolute winner. Then this is imbalanced data set. Let's look at the F1 score. So for F1 score, so I just ran this one. For F1 score, the Random Forest 47, Adaboost 44.5, 48, right? Again, Adaboost is the best one for this specific task, for this specific data. But again, the speed-wise, the XGBoost is really, really good. So if I want to look at the combination of performance versus and the speed, definitely XGBoost is my winner. And just like any other decision tree based models, we can do some feature importance, right? So I'm going to save the features. And then, so here, actually, let me remind you what are the list of features. These are the features we have. And because I want to do a bunch of feature importance from different models, I'm going to put it in a nice data frame, right? So I created the array, call it Random Forest importance. So this is from my classifier, Random Forest classifier, give me the feature importance. From Adaboost classifier, give me the feature importance, and etc. So I can run this. I can show you one of them to just make sure that you're following. So for example, if I look at this Random Forest importance here, Yeah, this is basically the feature importance corresponding to these columns. So limit balance, random forest, feature importance 0.059. And obviously we have different arrays for different of these models feature importance. I'm gonna stack it in a nice data frame. So pandas data frame, dictionary, and then features. These are columns and column names, and then columns values, right? Random forest, Adaboost, GBM, XGBoost, and I'm gonna sort them by the feature importance of random forest. You could do by XGBoost, but again, I just when it comes to boosting models or decision tree based models, I prefer, when I want to report the feature importance, I really prefer to work with random forest because it has fewer hyperparameters and it's more stable. The feature importance is more stable in general. This is not fact, but in general, on average, it's better. So yeah, this is what we get. And if you sort it based on random forest feature importance, we go from the least important, which is marriage, sex, education, to most important, which is pay, age, and etc. Okay, this is consistent with what we had in the previous lectures as well, especially with the Pycaret. I remember in Pycaret, the age was the second most important one. Here, that's the case as well. Interesting. But we can visualize it for random forest feature importance. We can visualize it for any other. So let's do, for example, for XGBoost. What do we call it? We call it XGBoost feature importance. So let's do that. Oops, I need to copy this. So let's copy this, paste it, and let's look at the feature importance for, yeah, there you go. This is for our XGBoost, right? And again, the previous one was for the random forest. So we sorted based on random forest. That's why we see things like this. Okay. So yeah, so that's pretty much it. If you want to do scikit-learn and XGBoost, if you want to do Pycaret, it's even easier, right? So everybody is already built in. So let me go ahead and run it quickly. So import the data frame, and then let's pre-process the data, and let me show you the list of the models that you have access to. So let's find our boosting models. From the top, we have, this is our benchmark, random forest. Then we have Adaboost, we have gradient boosting, we have XGBoost, we have LightGBM, and we have CatBoost. And if you want to see where the Pycaret is reading those things, if you ever wanted to look into the documentation, this is the source, right? So for, as you can see, for random forest, Adaboost, GBM, we are using scikit-learn. Scikit-learn ensemble, scikit-learn ensemble, scikit-learn ensemble, right? For XGBoost, obviously we're using XGBoost. For LightGBM, there's a package called LightGBM. For CatBoost, there's a package called CatBoost. Okay, so we can go ahead and create our boosting model, our XGBoost like this. Create model, estimator, XGBoost. That simple. It's going to do 10-fold cross-validation, and it's going to report the average F1 score, for example, 46%. Okay. Why am I looking into F1 score? Because this data set is relatively imbalanced. You can look into accuracy as well if the data set is more balanced. Again, this one is not crazy imbalanced, so I can still work with accuracy too. We can create this Adaboost, and you see the XGBoost was relatively the fastest. The Adaboost is going to be also fast, right? And then, well, relatively fast. But GBM is going to take longs, right? So I'm not going to run the GBM. So we're done with Adaboost here. So kind of the same performance. Well, this is on average 46%, on average 43%, with a decent value of standard deviation. Both of them standard deviation of around 2%, which is okay. All right, the GBM, just for fun, let me run it and see how long does that take. But this should take longer, right? Because we know that the GBM, for each GBM, it took 10 second-ish. So we have 10-fold. So this is going to take, I don't know, 100 second-ish. Well, of course, it's not linear. It's 15 seconds, but it was a lot more than the Adaboost or XGBoost, right? So our XGBoost is 3 seconds, Adaboost 5 second-ish, GBM 15 second-ish, right? Okay, and then the LightGBM, this should be fast too. Okay, and this was super fast, right? So that's why it's called LightGBM. So we talked about it in the theory lecture. You know, the search algorithm is different among these things. Let me actually pull it up quickly, show you what I'm talking about. You can watch the theory lecture module 10 part 3 to go over the details. But depending on how we answer these 4 questions, we come up with different models, right? What features and cutoff to start with, how do we split the data, how do we grow a tree, and how we combine these trees, right? And this is a nice table comparing, let's see at the very end, comparing these models, right? So just make sure you check out this video, and then hopefully you have a good understanding of the difference between these models, because in terms of application on the surface there's no difference. You just remove this LightGBM and replace it with XGBoost. So that's not the best way to do machine learning, right? So you have to understand the theory decently good enough and then do the Python part. Yeah, we have CatBoost as well. You know what, now that we have run everything, let's run CatBoost as well, because I'm curious to see how long does that take. But this is, again, more specifically designed for models that are handling lots of categorical variables, and that's not the case here. Yeah, this is taking 17 seconds. Performance wise, they are relatively the same. So 46.9, 47 LightGBM is better. 47.22 GBM, well, not surprisingly, was also good when we use Scikit-learn. This is our Adaboost, the least performer in this case, and then XGBoost is 40. All of them are decent, right? And they're comparable. And yeah, and we're not doing a competition here. You know, if it is a competition, you are just basically looking for 1% increase or 2% improvement. You can ensemble a bunch of these models. You can make a meta model, put the top 3 boosting models, let's say XGBoost, CatBoost, LightGBM, they put it together, making another meta model, and then you can get an improved performance. And that's going to be a winner for a Kaggle competition, for example. Okay, so we can look at the hyperparameters. There's so many hyperparameters when it comes to XGBoost, right? And these are the hyperparameters. And then we can do ROC AUC, confusion matrix, classification report. We have seen these things before. And this is our beautiful decision boundary in 2 dimension. And this is our learning curve, right? So the learning curve for XGBoost, it looks promising. It's decreasing, and this one is increasing, it's converging. So this data for XGBoost, at least XGBoost here in this example, is begging for more observations. So we're gonna, hopefully you can collect more data and then make this even better. And feature importance, pay 1, pay 2, pay 3, pay 4. So this is the feature importance for XGBoost, right? And yeah, that's interesting, right? And by the way, well, let me see if I have, did we train XGBoost? Yeah, we train XGBoost. If you want to do all the features, because by default it's going to give you just the top ones. If I do feature underscore all, it's going to give me all the features. So if you were wondering, hey, we had 23 features, where are the rest of them? So here are the rest of them. So yeah, cool. So let's see, feature. There you go. That was pretty much it. I think there's one last thing I wanted to show you, and that's the model container for Pycaret, right? So let's go ahead and open that one. So this is Pycaret model container. The link is here. So if you go back, the link should be at the very top where we started the Pycaret thing. Sorry, I'm not trying to give you a headache here, but just close your eyes when I'm scrolling up. Okay, there you go. So here it is, you know, model Pycaret model container, and go to classification. Open up, well, search for XGBoost. Yeah, there you go. So these are, let's see. Yeah, these are our tuning. These are our hyperparameters that we need to tune, right? So there's a lot of them, but what do we have? So for example, we have learning rate, we have number of estimator, all the way go to 300, subsamples, max depth, and then child width, regularization alpha, regularization lambda. So these are the hyperparameters for XGBoost, right? So there you go, you got this now. All right, so hopefully you enjoyed it. Until the next one, take care.